David Epicbow. Welcome to another episode of Tectonic Tangles. And by Joe, do we have a tangle for you today. Today we're discussing the simply fascinating class of high-grade metamorphic rocks called eclogites. And really, what are eclogites? Let's go inside and take a look, shall we?
Oh, there we are, back in the lab to discuss these fascinating eclogites. So what makes these eclogites so special? As you can see in this little diagram we knocked up earlier, it's a temperature on the top, pressure down the side, and as you can see the eclogites sit down here in the high pressure, high temperature regime. Now you don't need to be the sharpest pencil in the box to tell these conditions aren't found on the surface of the Earth. So how do these eclogites get there? Well, that's a question for later on in today's program. For now, let's talk about the minerals in eclogites. And really, any excuse to get my rocks out, if you know what I mean. What we've got here is a great, delicious specimen of eclogite. Let's have a look at the minerals inside it, shall we? So what we've got here, classic eclogite facies. We've got garnet and some amphicite, which is a type of pyroxene. I mean, amphicite, not really the name that I would have gone for, but it gets the job done. So, what we've got here in the eclogite facies is garnet and pyroxene. Now, really, these minerals, as we go up to the surface, they should break down into different types of minerals, but we still find this stuff in present day. So really, how does it get there? We normally find these in subduction zones and collision plates. We get these big up-thrusting plates that push this stuff up real quick. This stuff doesn't get a chance to change. Now the Himalayas, that's a classic example of a collision zone where we get these delicious eclogites. Now, as who's going to discuss eclogites?
Hello, my name's Tesla Hindenburg, and I'm a friend of David's, and I'm here today to talk to you about eclogites in the Himalayas. I'm going to begin by telling you about the evolution of the Himalayas. Roughly 90 million years ago, India and Asia were separated by the ocean that we now know as Tethys Ocean. The northern migration of the Indian continent led to the collision of these two plates, which ultimately led to upthrusting and the formation of the Himalayas. These tectonic forces that led to this northern migration were driven by the oceanic lithosphere. Basically, it's cold and old, and therefore could be subducted into the mantle. Now, let me start by showing you a model that I made when I worked at the Tectonics Observatory. As you can see, India is migrating more and more northward. Let's stop it here. You've seen that the oceanic lithosphere has continued to subduct into the mantle, and India and Asia have had their initial collision. Now stop, yes. So what you're seeing is that there's been a rollback of the oceanic lithosphere, and this has led to its break-off. This break-off, in fact, led to the isostatic rebound, which led to the initial upthrusting of the Himalayas. Continue. What you're seeing here, if you would stop it, is that India is now underplating Asia, which is leading to more and more upthrusting, so more and more formation of the Himalayas. And now, just to put it into context, this is what present day looks like. Now I'm going to show you another video that I made, which looks more closely at this underplating of India under Asia, and we can also look in the context of formation of eclogites. Okay kids, I'm going to talk to you. Don't you give me that face. Stop it. Righto, now let's look at the Himalayas in the context of the formation and the exhumation of eclogites. Consider this sandbox model I made some time ago that exhibits the Indian continental plate underthrusting the Eurasian plate after the subduction and break-off of the oceanic lithosphere, which, if you remember, we saw in the last model. Now, there's some key features I'd like to point out to you. This is basically the Indian crust, the Indian lithosphere and the mantle. This is the Asian crust, the Asian lithosphere and the mantle. But more importantly, let me show you where are good areas for the formation of eclogites. At the contact between the lithosphere and the mantle, there's very high temperatures and pressures, so this is quite a nice place. Eclogites love it. This part here, though, is what I'm going to focus on in this model, and what I would like you guys to just watch to the progression of this model. This is the contact between the Indian and the Asian plate, which has very high pressures, and as we know, because it's close to the contact between the lithosphere and the mantle, very high temperatures. Now, let me just grab a drink. I'm a bit parched. There we go. Right, so let's begin. As you can see, there's underthrusting and thrusting. If we stop it here, what you see is that there's been continued underthrusting of this Indian plate under the Asian plate, and this has ultimately led to the rise of these eclogites. As you can see, they were once down here and now they're here. What's quite essential is a process called serpentinization. Serpentinization has basically led to serpentine material encasing the eclogites, and this ultimately leads to a density contrast, right? Because the serpentinized material is lighter than the dense eclogites, which also makes this piece of material here more mechanically slithery, which facilitates in the movement of eclogites upwards. So yes, so don't forget that when you're thinking about exhumation of eclogites, serpentinization arrives. So if we just continue this, continue the model. Yes, thanks. Right, and just watch it. Oh, sorry, could you just keep going a little bit more? And stop it here. Right, so you've seen it, it's continuing to rise. It was down here before, if you remember, and now it's here. Right. So, what we've got here that has added to the rise of these eclogites is basically we've had some imbrication. And this here, these are the imbricates, has formed due to brittle failure. And what you've seen is that basically as these two buoyant, light continental materials go towards each other, and as we know this, instead of leading to subduction, leads to collision, you've got a stack up of material like this. And basically the continued stack up will get higher and higher, which is pushing these eclogites that were once down here at the base of the asthenosphere and the mantle are now up here. So imbrication is quite an essential process as well. Brittle failure is the key. But if you continue, and you watch it, it gets higher and higher, and now look, there you have it. We've got them. They're at the surface. We can see them. We can traverse and find them. Yes, it's exciting, isn't it? Basically what's happening, I don't know if you've been watching, if you've had a keen eye, is we've had erosion occurring on the surface. And as the imbrication and the addition of serpentinization has made the eclogites rise to the surface, erosion has basically led to bits of the surface being taken away, and there you have it. Eclogites at the surface. And also, I don't know if you remember, I told you before that here on the Asian plate where the lithosphere meets the mantle is quite a nice place for eclogites to form. If you watched at the beginning, they were down here, and when this plate was here and this plate was here, they're basically being thrusted up to the surface. So, you know, the underplating has also resulted from eclogite formation on this eastern side to be forced up. Right, so now I'm going to give it back to my friend David, because he's spectacular. He's going to tell you about one more process that is quite essential for the exhumation of eclogites, something called isostatic rebound.
Yes, thanks Tesla. What do you reckon, people? I think she needs to lighten up a bit, have a few more of those Venus, Right, so we're talking about isostatic rebound. Sounds like an incredibly complex process, but really, it's quite simple. All it is confining pressure being released exceptionally quickly to liberate something upwards. So, what we've got here is, if you can picture this, this is a subducting lithosphere that we saw on the convergent plate boundary. You had the oceanic lithosphere being pushed underneath the ocean plate. So, okay, this is the crust. If you'd like to play this little movie that we prepared earlier, okay? So it's being compressed down. So compress, compress, compress. Now, as we get down to the bottom, it's here somewhere, about there. Yeah, that's right. At this point here, you've got the lithosphere meeting the mantle. Right down the bottom, this is where your eclogites form, as we've discussed. High pressure, high temperature. So right here is the eclogites. Now you can imagine that roll off of the lithosphere in the ocean. That break off of that cold, heavy plate liberates the lithosphere upwards in this amazing rebound event. And that's really what is the initial driving force of the exhumation upwards of the eclogites. Okay. So if we'd like to play this movie again, please. So, at some point, could be any time, there it goes! So that was the lithosphere breaking away and the eclogites being forced upwards in the first thrust of the mountain range. So we'd have to have a little trajectory. So if you can imagine, this was the plate being subducted down underneath, following this line here, and then it's equilibrated near the mantle to form the eclogites right here. Now, because of that isostatic rebound, gets forced quickly back this way before these little delicious minerals get a chance to re-equilibrate. This is why we find them at the surface preserved like this. These little delightful little garnets here. Let's spend time with it. So, the last piece of the puzzle, so we've seen this isostatic rebound. The last piece is erosion, which is a more pervasive and passive kind of process of isostatic rebound, where it just removes the layers and overburn it with tons of these thrusting plates being removed, and that allows for both the exhumation and the exposure of these eclogites. So, fascinating really, isn't it? So in summary, you can see these eclogites form in convergent zones where they're first thrust down, exposed to these amazing pressures and temperatures before underplating, subpentonization, exhumation and erosion brings them back to the surface for us to see today. I think that's pretty fascinating. So, I'd like to bring out Tesla here, and we'd like to thank you for joining us in our latest instalment of Tectonic Tangles. I think and I hope you've enjoyed yourself tonight. Thank you.